Hi, I'm Rufus Connell with Frost Sullivan. I'm here today with Brad Boston, and you're a Senior Vice President now in charge of Satellite Solutions at Cisco. And perhaps maybe we could start off by talking about just how the Iris solution is enabling this evolution of the network.
Sure. So if you think about the satellite networks today, they look a lot like the phone companies did 25 years ago. Today, most satellite networks are all bent pipe type of configuration. So what that means is, if I want to send a message to you and you're someplace else under the same satellite coverage, I have to send a transmission to the satellite, which then sends one down to a teleport to go identify where you're at and then send it back up to the satellite to send down to you. So it actually makes two round trips, 22,000 miles to the satellite to get that communication to you. What we're able to do with the Iris technology, especially if you're under the same coverage of that satellite, whether it's the same transponder or different transponders that are managed by the Iris solution on the satellite, we can go up to the satellite. It determines that, oh, you're over there still under our coverage, either on the same transponder or a different transponder, route it on the satellite and come back down. So we eliminate an entire round trip, as opposed to what we're all used to with satellite voice and actually video communications, where there's that awkward pause. You know, so everyone's seen the satellite transmission from someplace within the world live on TV, where the guy that's at the remote location has to sit there and wait, hear the whole question because there's a couple second delay, and then go and respond. So that we eliminate that awkward delay by doing that.
Now, you mentioned that you're on Intelsat 14, and that's a geosynchronous satellite over at the Atlantic. What's the roadmap look like for going on to other satellites?
We have a number of initiatives going on with various operators and service providers to take the radio access network technology that we've adopted for satellite and deploy that with next generation IP networks for their terrestrial component. And then we're having discussions with several operators about how to incorporate a space router in future satellites that they're going to launch. And then in addition, we're talking to a number of satellite manufacturers about how we can take the space router and integrate it with technology that they've developed to go and more flexibly manage the transponders on a satellite.
So one of Cisco's core pillars is always leadership in routing. And obviously going to space is really hard. And there's just different power requirements, there's different packaging requirements, there's different radiation issues. You know, are we going to see the sort of advances that you have to make to be in that space come back into the data center?
So as the geometries of electronic circuits, whether they're processors or FPGAs or ASICs, as they get smaller, thinner, and denser, they start to suffer the same radiation effects at sea level as we see affect larger kind of electronics in space. And so some of the things that we're going to learn on error correcting can apply to their design of future circuits here terrestrially as well.
Do you see the service provider taking advantage of that, or the end user taking advantage of that? How is that going to play out?
So we see there's an opportunity for the satellite operator to take advantage of the technology and get a better return on their investment. There's the service providers such as TCS or such as AT&T, Verizon, British Telecom, folks like that. We can fundamentally change the way they offer satellite services to their customers. And then there's the end users that have the opportunity to be able to build mesh networks and be able to procure and utilize satellite services in a much more cost-efficient manner going forward. So we see benefits for all three of the players in that supply chain.
Sure. Now, do you see any particular trends that are affecting either the operator, the government agencies, or even the commercial end users that are really driving adoption of these services?
So the big trend that's going on in the industry today is the move to Ka-band transponders, which are higher throughput, higher capacity transponders. So good news is it's driving the cost of bandwidth down. The badness with that is it's still not dealing with the efficiency and the operation issues. So if we can marry the router technology together with the change to this higher throughput radio technology that they're using, we can create a much more prolific offering for the operators and the service providers.
Brad, I want to thank you again for spending the time with us today. And again, I want to take the opportunity to congratulate Cisco Systems on its 2012 Global Satellite Transponder Technology Innovation Award. Thank you for spending the time with us today.
Thanks for having us.